This video is for viewers who do not like comfyUI and find it hard to understand. Let me try to make it simple for you. Right now, we are looking at the default workflow for text-to-image generation, which is generating images using the Stable Diffusion 1.5 model. To begin, I will press Ctrl, left-click, and drag the mouse to select and delete the basic workflow. Now, let's create the workflow ourselves. Which node will you start with? I will double-click this empty space, which will bring up a search bar to find the node. These are the nodes currently available in comfyUI. On the left, you can see the node names, and on the right, they are labeled as Comfy Core. This means that the node you're looking at was added during the installation of comfyUI. It is part of the core functionality of comfyUI. At the top, this node has a different origin. It comes from the comfyUI team, but is part of a separate, downloadable function called the Video Helper Suite. This is one of the reasons why comfyUI is better than other interfaces. We can always add new features in the form of nodes without affecting the entire application. Have you thought about which node to start with? If you're unsure at this point, I suggest recalling the workflow I just deleted. There were multiple nodes. Just take the one with the most connections. It will bring the entire workflow with it. That node was the K-sampler, which takes 4 inputs and provides 1 output in a latent form. If you look on the left, it takes a latent image. When I click and drag, a connection emerges from it, and when I release the left mouse button, I get these options to add nodes, along with some recommendations. I need the empty latent image from the recommendations. Why this latent image, you may ask? The K-sampler takes a latent image specified by us and operates in latent space. This latent space is a compressed representation of an image, so it is more efficient and practical. It does all the work inside latent space and gives an output straight from the latent space. The output of the K-sampler is a latent representation, not a conventional image. The VAE decoder is used to convert the latent representation back into a normal image. So now you know there is something called latent space, and everything happens inside that latent space. There is no point looking inside latent space or the latent image. We need the VAE decoder, which converts the image from latent space to a normal image. This decoder takes the latent image and the VAE as inputs to produce a normal image on the right as output. In K-sampler, there are a few more requirements on the left. The first is for the AI model. This load checkpoint node will be used to load the AI model. Note that the connections we make can only be established with similar colored points. Next, we can have the VAE connected, indicated by the orange dot, which can be from the load checkpoint node. You may wonder why we use a VAE. The AI image generation process relies on a checkpoint that includes a UNet, which contains information about numerous images that can be used to generate a new image. Additionally, there is a text encoder that converts our text into a format that can be understood and utilized during image generation in latent space. The third component is the VAE, which, in relation to the UNet used for generating an image, is responsible for converting the latent representation into a visible image. While the terms I am using may not be entirely precise, but I believe they are the best way to explain the process to a non-technical audience. Now we have the positive and negative points remaining. These represent the text we type to generate an image. I will right-click to search for the node, but you can also drag the connection and get it from the recommendations. Under conditions, there is the clip text encoder prompt. There are 2 of these, so I will bring in the node again. Now we have both the positive and negative prompt nodes in the workflow. The text we type here must be converted, or I should say encoded, so that it becomes compatible in latent space. To do so, we will connect the clip connection to the clip text encoder node. The checkpoint of Stable Diffusion 1.5 contains the AI model, VAE, and text encoder all in a single file. That's why there are multiple outputs connected to the respective nodes. The last remaining component is the VAE decoder, which returns an image, but there should also be something to display the image. In the suggestions, there are two options: Save Image and Preview Image. I do not want to save the image, so I will use the Preview node. Even without any prompt, if I run the workflow, I should get an image. The selected checkpoint here is Stable Diffusion 1.5, and remember, I mentioned that the checkpoint contains the text encoder and the VAE all in a single file. Now the workflow is complete for both SD 1.5 and SDXL checkpoints. I will type a prompt, a kid, in a Superman costume, and then cue the workflow for processing. When I receive the image, I notice that the quality of the generated image is low. The face and hands are not clear or well-defined. If I try again, the generated image remains of low quality. This is due to the base model of Stable Diffusion 1.5. Note that there are multiple models on Civit AI's website that are fine-tuned to produce better quality images, such as this model based on SD 1.5. The next model to consider in this workflow is the SDXL model. I will search for it and find the SDXL base model on Hugging Face. As the name suggests, this is the base model, and I will download it. The model below appears to be a fix for some issues that were identified after the original model was released, incorporating a different VAE. In the Load Checkpoint node, the model nodes are not found. Press the letter R to refresh, and it should be visible now. I will leave everything as it is and cue the workflow for processing. It may take some time for the first image generation because the models need to be loaded. Now I have the result. The face looks better. It's not perfect, and the hands are deformed, but the overall image is better than what we saw previously. I want to remind you that this is the base model. Civit AI has multiple fine-tuned SDXL models that can generate better results. I am downloading last year's Juggernaut model, which is based on the SDXL base model, meaning this Juggernaut model was created using the SDXL base model. I will refresh by pressing the letter R, and the model should be there now. Select the model and cue the workflow. The result is somewhat better. However, the eyes still have issues, but the overall image looks improved. Both the SD 1.5 and SDXL models require a negative prompt to generate better results. I will copy the prompt from Civit AI and paste it into the text encoder connected to the negative point of the K-sampler. The image looks fine, but you may notice unclear fingers when using SDXL models. The fingers can be fixed. I can make a video on this if needed. Let me know in the comments. These SDXL models are actually trained on larger images compared to the SD 1.5 models. Therefore, the best SDXL images can be generated at a size of 1024 pixels. Please note that generating a larger image will require more resources and time, but these images look better. Let's move ahead and look at Flux models. I will search the internet for the base model. This is the base model, and its size is around 24 gigabytes. My graphics card has only 16 gigabytes of memory, which means I will not be able to load the model onto my graphics card. The models here are intended for computers with GPUs that have 24 gigabytes or more of memory. If I check for another model by the same user, Black Forest Labs, this is the one we just saw. And here is another model. This Schnell model is faster compared to the previous Flux 1 dev model. However, due to its larger size, I will not be able to use it either. To make these AI models practical for consumer-grade hardware, a different GGUF model was released on Hugging Face. If you search for Flux GGUF, the first and second results will show the model. This Hugging Face ID, named City96, has uploaded both the Flux 1 Dev GGUF model and the Schnell GGUF model. Right now, we are looking at the dev version of the model. These models are designed for low memory cards, starting from Q2 to Q8. The larger the number, the larger the model. On the Another tab, this user had also uploaded a copy of GGUF models for both the versions of Flux. If we check more by this user, there is one more type of Flux model for lower VRAM cards, the BNB NF4 model. This is a checkpoint. I hope you remember I mentioned that it contains everything in one file. And I see there are two models available here. A second version of the same model is available. Back to City96, I will download this Q6 model to show you the workflow. The previous model was kept as a checkpoint, but the one I am downloading right now is not a checkpoint. This is a UNet model, so it goes inside the UNet folder. Since this is not a checkpoint, I need to have some additional files to use along with UNet for it to work. These files will include the text encoder and the VAE. I will search for Flux text encoder. This user, comfyAnonymous, has the file we need. The clip.l file and one of the T5 files are required for the text encoding process. If you have a question about how I know which is a checkpoint and which is a UNet, I usually check the source where I download these models. For example, here in the model card, it specifies to keep it inside the UNet folder. Similarly, you should find this information on Civet AI's website as well. Also, check the comments for such information. So I will download the clip.l file and save it inside the models and then the text encoders folder. There are multiple T5 files. I have used these too, so let me try the third file this time and save it inside the text encoders folder. The second requirement is the VAE, so I searched for Flux VAE. You can download it from here. You need to be logged in to access this content. I believe there may be other sources as well, but I will just log in and go to the main folder. Below is the file, named as ae.safetensor. You can rename the file if you wish. Download the file and place it inside the Models folder, and then into the VAE folder. The user by the name City96 had also uploaded the Schnell version of Flux model, should be there below. The Q6 model I downloaded a minute ago was the Flux Dev GGUF model. If you want a faster model, then you should be looking at the Schnell version of GGUF model. Please note that while these models are fast, they may come at the cost of quality. To start with the GGUF model, we first need to look at the manager, then the custom node manager. Let me show you the installed nodes in comfyUI manager. You need to have these comfyUI GGUF nodes to use the GGUF models. The nodes I currently have are the manager and the GGUF node. These both were installed for AI video generation while making previous videos. You should find the GGUF node by setting the filter to all and typing GGUF in the search box. This is the one, and on the right you should see an install button like this. Double-click and search for GGUF. You should see the UNet loader. If it's not visible, press letter R to refresh. Select the Q6 model. We need to replace the above connections of the checkpoint node with the GGUF nodes. With this UNet loader, I have managed the model's connection. The second connection is this yellow dot with a title clip. I will double-click again to search for dual clip. I found the dual clip loader from the GGUF notes. You may ask, why dual clip? Because there are two files for the clip text encoder, clip-L, and the T5 files. And the clip type will be Flux. Next is the orange dot for the VAE. I will search for VAE, and this load VAE node will work. Now I have all the three connections similar to the checkpoint node. I will disconnect the model connection and connect it to the GGUF node. Next, I will remove both connections from the prompt node and establish a connection with the dual clip node. Double-click and rename this to negative prompt node. I should have done this earlier. Actually, in the case of the Flux model, we do not need the negative prompt. So I will use the collapse option to make it shorter. The connection of the negative prompt in the K-sampler is required, but the negative prompt will not be used while generating an image. I will remove the last connection from the VAE and connect the load VAE node to the decoder. I can delete this now. I also forgot to select the VAE file in the node. Select the ae.safetensor file. The CFG, or I can say the guidance scale, in the K-sampler should be set to 1.0 because Flux uses a different node for the guidance scale. The sampler name can be changed. I prefer DPMPP2M as it works most of the time. The scheduler can be set to SGM uniform. Keep the image generation steps around 20 to 30 for Flux 1 dev models. In the case of Schnell models, keep it around 5 to 8 steps. I think I should try queuing the workflow for processing, and it did not work. I must have missed something. A minute ago, I mentioned that Flux uses a different CFG node, but I forgot to add it. It should be connected with a prompt, so I will remove this connection and search for guidance. I found the result, Flux guidance. I just need to make a few adjustments. This should be placed in between and connect it with a prompt and the K-sampler. The CFG, or I can say classifier guidance scale, refers to how closely the prompt we provide should be followed by the AI. I will try generating it again. However, I failed once again. I am confident that I haven't missed anything this time. I do have a question about the different T5 file I downloaded. The one had scaled in its name. I will download the file I have used before and place it inside the text encoder folder. In the clip loader, I will select the new T5 file and the clip-L file. It should work now. And it seems to be functioning correctly. The image generated by Flux is certainly a high-quality image. The fingers are accurate, the body looks good, and the clothing appears to be of good quality. Now you can generate images using the Flux Dev and Schnell GGUF UNet models with this workflow. You can obtain the models from Hugging Face or from Civit AI's website. I can include the links in the description. Let's look at another type of model now, the BNB model I showed earlier. Inside the files and versions, you should see two versions, and I will download the second version of the model and save it in the checkpoint folder. From the same user, I will also get a Schnell version of the Flux model to demonstrate that it works in the same workflow. This Q6 model should work, and I will save it in the UNet folder. In the workflow, I will refresh by pressing the R button, then select the Schnell model and run the workflow. I forgot to change the number of steps. The result had a missing hand. I changed the steps to 8 and got a decent result. I tried again, and the result looks good. At last, I will try the BNB model. To get it working, I need to install the BNB nodes. Inside the Custom Node Manager, search for NF4. You should see the bits and bytes NF4 node by a user named Silver Oxides. I checked on GitHub about it, and it states that NF4 is not supported by the comfyUI team, but a reference to this user is provided. It looked fine to me, so I decided to install it. I selected the latest version, then restarted and reloaded comfyUI. Next, I double-clicked and searched for NF4, and we got two results, a UNet and a checkpoint loader. I am sure the file I downloaded is the checkpoint, contains the UNet, VAE, and the text encoder. So I clicked on the checkpoint node and selected the model. I disconnected the previous VAE and connected it from the checkpoint node. I also disconnected both prompt nodes and connected them to the clip of the checkpoint node. I made some adjustments to ensure everything is visible. At last, I disconnected the model from the K-sampler and had it connected to the checkpoint node. I think it's done now, so I will queue it for processing. The result is good. I kept the number of steps at 5, which is from the Schnell model, but the NF4 model produced a high-quality image. You can increase the steps and experiment with it. I hope the video was helpful, and now you can easily generate images using stable diffusion and flux models. The larger model, which I was unable to use, will also work with the same workflow I showed in the video. You just need a graphics card with more memory to load the model.